Guys, welcome back to the next lecture. So today we'll be moving on to part 3 of the series. Now today's will be a small lecture compared to all the other videos. I hope so. So today we already studied about functions. We studied about different kinds of functions, and we studied how something can be called a function, what are the conditions in which we can say this is a function. Now when we have two functions, there are different things that we can do, that is different operations that we can do. So let us look on to few operations. So here I'm going to mention 5 operations. So we can always do addition. If we have two functions, we can just directly add them up. If we can always do subtraction. If you have two functions, just subtract them directly. You can always multiply two functions. You can divide two functions, just divide them up directly, but there is a condition here, that is the denominator should never be 0. When you do division operation, the denominator should never be 0. Then this is another operation that is called scalar multiplication. Scalar multiplication means you are multiplying the value with a constant. Basically that is all. Multiplication, what we did was we multiplied the functions directly. In scalar multiplication, what we do is we multiply with a constant value. K is a constant value here, so just directly multiplying it, that is all. So these are few operations that we can do on functions. Now there is one more thing that I want to teach you, and that is Cartesian product. Now what is Cartesian product? Let me show you an example first. I have one set called A, 1 2 3 4 5 6 7 8. I have another set called B, high and low. So Cartesian product is represented like this, that is A cross B. It could also be represented as B cross A. Here I'm going to say A cross B. So how will I write A cross B? I'll show you the answer first, then we'll tell you how to get it. A cross B will be represented like this. So what I have done here, if you look carefully, you will see that I have made a relationship between every element of A and every element of B. That each element of A, I have made a relation with each element of B. That means every element of A has a relationship with every element of B. 1 high, 1 low, 2 high, 2 low, 3 high, 3 low. Every element of A has a relationship now with every element of B, and that is called Cartesian product. Guys, remember, this is not a function, because a function, one input has only one output. Now here we see, for 1 as the input I get output high, for 1 as the input I get output low. So that means there are two outputs for the same input. So this is not a function. Okay, make sure that never say Cartesian product is a function, because there are multiple outputs for the same input, which is never allowed. So this is a relation. Cartesian product is a relation. That is why I'm saying the word, I'm using the word relation again and again. Cartesian product is basically relating every element of one set to every element of the other set. Okay. Now I showed you A cross B. Let us look what is B cross A. The same thing, but each pair is interchanged. That means 1 high becomes high 1, 5 high becomes high 5, 7 high becomes high 7. So it's just interchanged. That is all. Now you might say, you might ask, come on sir, what is the issue? 1 high or high 1, what difference does it make? Same thing. No, it is not. Let me show you by an example. You all studied about graphs. So let me draw a graph here, and I will put some values 1, 2, 3, 1, 2, 3. Now if I tell you to mark the point 1, 3, where will you mark? It will be 1, x1, y3. Okay, so I didn't write, this is my x, this is my y. So this will be my point 1, 3. Now let me interchange the 1 and 3. If I interchange 1 and 3, it will become 3, 1. Now where is this point in the graph? X is 3, y is 1, it will be here. So now do you see the difference? 1, 3 is here, and if I just interchange the elements, it will become here. So this is why I am saying, this is one reason, or this is one example why I say A cross B is never B cross A. See, if you look, the number of elements is the same. How to find the number of elements? Here there are 8 elements, B 2 elements, 8 into 2 there are 16 elements. A cross B and B cross A both have 16 elements, no doubt, but both are not the same. That is, A cross B and B cross A are not equal, never equal, because the order of the elements are different. So this is all that I have to say today, and this is the class for today, and by this our chapter also gets over. Guys, make sure that you are very thorough with whatever I have taught in this chapter, because it is on this topics that in the next year, in 12th, you will have more things to study. You will have the same chapter, relations and functions, with more things to study. So it will be on this foundation that those things will be taken. So make sure that you are very thorough with things that are taught in this year. Okay, so thank you for listening. Bye bye.